alcohols exam style questions. We're going to go through the type of question you get, typically 6 marks, where you'll be asked to design a practical to do with converting a primary alcohol to an aldehyde, or a primary alcohol to a carboxylic acid, or a secondary alcohol to a ketone. So let's have a look at our first one. Design a practical to synthesize ethanal from ethanol. So we're making it from that primary alcohol. We're going to make ethanal. Ethanal has a boiling point that's far lower than ethanol. And the other product you can get is ethanoic acid, and that ethanal is far lower than both of those. Notice that the boiling point is actually lower than 78 first, then 118. So that's really important. We're doing an aldehyde, so therefore we have to do distillation, and we have to show the water in and out on that distillation. Now let's draw the distillation. Let's move this over to the side. And then from there, let's remind ourselves the lowest boiling point is ethanal, which is why we're doing that distillation. And let's look at the laboratory apparatus. So here we have all of our laboratory apparatus, but the most important thing is our labelling-wise thermometer, Rambot flask, our condenser, and our ice bath. But let's rearrange these into the distillation apparatus. So we've rearranged those into the distillation apparatus, and we've got a question back up here. Design a practical to synthesize ethanal from ethanol. So we know, and this is a really important thing, that the next highest boiling point is ethanol. So if we want to boil off the ethanal, we have to keep the temperature below the boiling point of ethanol. And in a sense, that will be lower than the ethanoic acid as well. So we have to keep that temperature lower. So that's why we heat it, as you can see here, less than 78 degrees. I'd pick a temperature if I was you. I'd pick something like 60, 70, something like that. Just something that is lower than the actual boiling point of the alcohol that is there. Now at that point, okay, you also have to do this drawing in and out. I just want to go through very quickly this in and out here. The water comes here and then goes up and pushes the air out. If you put the water in at the bottom, it'll push all the air out, and that means that stays nice and cold, just like we've shown you in the lab videos in the previous video. Okay, so we then now move on to, let's put our ethanol and ethanoic acid in, and we've got a nice orange colour. They react and they turn into this nice green colour. And that's the colour change you need to remember as through all these kind of oxidation videos. From that point, the aldehyde will then start to boil off, and you can see the arrows forming here, and that aldehyde is boiling off. Nothing else is, because we haven't reached their boiling points. And then you collect it in the ice bath to keep it nice and cool so that the aldehyde doesn't evaporate, because remember it's only 20 degrees, so that ice bath is really important. Otherwise, as soon as the aldehyde comes through, it will start to boil off or evaporate off, because the temperature of the air is around 20 degrees. Now we've done that, and we've produced our ethanol. Now we want to know, why do we only produce the ethanol? Well, it's good to explain within the question, the only reason we produce the ethanol only is because the ethanol escapes or separates from the oxidizing agent. The oxidizing agent is the Cr2O72- and the H+, the acidified potassium dichromate, and it escapes from it. And as soon as it escapes from it, it stops reacting and won't get oxidized any further, because remember, it can get oxidized all the way to the ethanoic acid. Now in these questions, they also like to show you and ask you to do the equation. So often they'll ask you to do the equation as part of it. So let's do the equation here. We've got ethanol. Okay, so there is our ethanol. And then we're adding it to our oxidizing agent. There's our oxidizing agent. Okay, hopefully you can do this before me. Think about what you're doing. What are you going to do? What are you going to make? You're going to make that aldehyde. That's ethanol. So I'm going to do it in skeletal formula. There you go. You don't have to put that H on, remember, when you're doing skeletal formula. You can, but you don't have to. Okay, and then if I think about this, there is 2 hydrogens being removed, and therefore I have 1 H2O. So that's our balanced equation. So normally in these questions, they'll get you to design the practical, they'll get you to do the equation, they'll get you to draw, through the design, draw the distillation, and explain why this only creates the aldehyde and doesn't create the ethanoic acid as well. We're now going to focus on reflux. So we've got our different apparatus within the laboratory again, and we're going to turn it into the reflux apparatus and show you the next style of question. So here we want to design a practical to synthesize ethanoic acid, and we want to make that from our ethanol this time. That means if we want to do it, we want the oxidizing agent to be in contact with the ethanol the entire time, because then that will make the ethanoic acid. We don't want the aldehyde to escape, we don't want it to separate from the oxidizing agent, we just want to make the ethanoic acid. And that works if we do reflux. So with our reflux, notice we've labelled all the appropriate parts of the diagram, and we're going to do our water in and water out. And the water in and water out goes for the same reason. We're forcing the air out of the tube to make sure the tube is nice and cold. We then put our ethanol and our oxidizing agent into the round bottom flask, and you've got that orange colour. Okay, and it's worth just going over again that kind of exam question. Why do we only produce the ethanoic acid? Well, it's because it always stays in contact, as I said. It always stays in contact with the oxidizing agent. And so the whole thing goes to completion. So if that is the case, also in these kind of questions, they want you to draw that equation. So let's draw that equation again. If you can draw it first, draw it before me. So if I do, I'm starting with ethanol again. Okay, here is our ethanol. And then we're going to add our oxidizing agent to it again. So here's our oxidizing agent. And then we're going to go from there and we're going to make our carboxylic acid. Okay, important thing that you realise hopefully here is that you are losing 2 hydrogens to go from there to there, just 2 hydrogens. They're getting oxidised by the oxidising agent, and therefore you have 1 water. And that again covered in our previous video on how to do this, but that is mark worthy usually in questions like this. So not only are you going to design the practical like you have done, you are then going to do the equation. Now when the reaction goes to completion, again, I always like to remind you that orange will go to green. And the other thing is, why are we doing the reflux? Well, there's 2 reasons. One, we don't want it to escape, but the second reason is it allows evaporation and condensation, as you can see the arrows going up there. Okay, and then coming down. All that happens is that solvent evaporates, then condenses, and which means the solvent never escapes. 1, it never dries out, and 2, it's also much, much safer. Now that is how you do the reaction of a primary alcohol to a carboxylic acid, but this can also be done in exactly the same way if you're going to turn a secondary alcohol to a ketone. That is also reflux. This is also reflux. So if you are told to make a ketone, the same thing, it's just reflux. If you're told to make a carboxylic acid, reflux. So remember, ketone, carboxylic acid, from either a primary alcohol or a secondary alcohol, you always do reflux.